Next up, we're going to be graphing a transformed cosine function. Now again, how do we know the parent function is cosine? Well, you can see the cosine right here. It's whatever is basically being plugged into the parentheses, whatever it's being plugged into, it's just the cosine. So step one, just like in the last example, we're going to convert to standard form. We want this 3 to go to the end because that's our d value. We want this 2 to come first because that's our a value. And then we want to switch the pi and the minus x because we want our x to come first and then plus pi. And then don't forget, since it's negative x, make that negative 1. Now we can see a, b, c, and d. That leads us to our next step is to determine a, b, c, and d. A is going to be negative 1/2. B is going to be negative 1, C is going to be pi, and D is going to be plus 3. So it's going to shift pi units to the left since it's positive C. We're going to be subtracting that, and it's going to be shifting 3 units up. It's going to have a horizontal flip, and it's going to have a vertical stretch of 2. Step 3 is to chart the parent function. Now, at this point, you need to know, first of all, you need to know your x values. There's 9 of them for trig functions. They range from negative pi to pi. I've spent a lot of time on that. If you have any questions about that, feel free to ask me, but they start at negative pi and they go to pi increments of pi over 4. Our y values come from the unit circle and come from knowing trig really well, so make sure you know that really well. You can always go back and watch my videos on trig or ask me questions. I'd be happy to answer them for you. Also, don't forget that the square root of 2 is approximately 1.4. We want to convert each of these radicals to decimals so that we can put them on a graph. So I went ahead and did that. I know square root of 2 is 1.4, so if I divide that by 2, that's 0.7, and negative if that's the case. Okay, next step is to determine your new x values. So here are my original parent x values. Again, it's easy. You just take your parent x values, you subtract c and divide by b. Now in this case, c is pi and b is negative 1. So I'm going to take each of these x values, subtract pi, and then divide by negative 1. Again, I like to show every step possible in this column. And so if I want to combine these two, I have to write pi as 4 pi over 4, and then it becomes negative 7 pi over 4, and I'm dividing that by negative 1, so it becomes positive 7 pi over 4. And I did that each and every time to make sure that I get my correct x2 values. Those are going to be my x values for my f of x function, my transformed function. Again, if you have any questions about that, let me know, because I know there's a lot going on in that page. Okay, next up we're going to determine our function values, our f of x values, or our y values. Again, you're going to take your parent y values from your parent chart right here. Make sure you use the decimal forms. You're going to multiply those values by a and then add d to that. Okay? You can do p of x times a. I don't know why I just did a times p of x. It's exactly the same thing. Doesn't matter which order because of the commutative property of multiplication. So a times p of x and then add d. Not really much math to show here. For here it's 2 times negative 0.7, so negative 1.4 plus 3 gives me 1.6. But most of this is just straightforward. So these are going to be my y values for f of x. So I'm going to combine these x values, my new x values, with my new y values to make this chart. And that's going to be my final chart that I'm going to use to graph my transformed function. So after step 6 of charting those values, we're going to go to step 7 and plot them on a graph. Now, how do we do that? Well, for example, 2 pi comma 1 goes right here at 2 pi comma 1, 7 pi over 4 comma 1.6. 1.6 is somewhere between 1 and 2, and you connect them. You know it's going to be a wave because it's cosine, so you connect them with a wave. Now with this app, I'm not going to be able to get it exactly right because I can't make c equal to pi, but I can make it equal to 3 and make it pretty close. So first of all, it's going to have a horizontal shift 3 units to the left since it's positive 3. Next, it's going to have a horizontal flip because b is equal to negative 1. After that, a is 2 and d is 3. So when a is 2, it's going to stretch the graph. And d is, let me make sure I get this right, d is 3, so it's going to shift 3 units up. And we just plotted a certain strand of it over here somewhere. Let's see if I can go back and find that. And also my chart, the scale's a little bit different. But anyway, this just confirms that indeed. Hey, let's zoom in here a little bit. It's going to look a little bit better. There we go. So there's our graph, and those are all the transformations that occurred as a result. If you have any other questions about this simple process of charting function transformations and graphing them, let me know.